So, good morning, everyone, and thank you for joining us for the System Engineering Forum virtual series. To start, we are recording this event, so please keep that in mind. I am Alexander Chang, and I am serving as one of the co-chairs for the System Engineering Forum alongside Dr. Alex Trujillo, who is helping me today. I'll be helping to facilitate the event, transition slides, and capture questions throughout the briefing. Before I introduce our presenters, I'd like to provide a couple of housekeeping remarks. The System Engineering Forum, hosted by the Aerospace Corporation this year in collaboration with the Jet Propulsion Laboratory, focuses on applying innovative systems engineering principles across the space enterprise, contributing to mission success while advancing the state of the discipline that may be applicable to a wide range of audience members that you see below. Once again, this event is both unclassified and being recorded, including all questions and answers in the chat or by voice, and will be posted on our YouTube site and a link provided on the SEF archive page after the event. The presenters today ask audience members to use the chat box to ask questions, and they will address them as they are able, or at the end for a Q&A session. If you are asking a more complex question, please also use the chat box, and you will be given an opportunity to elaborate during the Q&A session, but please keep your devices muted and cameras off during the presentations. If you're experiencing issues while using Teams, please reach out to Dr. Trujillo through the chat. With that, we can begin today's events. Today's theme is Digital Engineering Ecosystems, where we bring presentations showcasing the perspectives that the Aerospace Corporation and JPL have taken to develop and implement their respective digital engineering ecosystems. Our presenters are the Aerospace Corporation's Dr. Erin Ryan on Aerospace's D ecosystem architecture and implementation, and JPL's Robert Karban and Hetav Patel on OpenMBEE, Connected Engineering Information for a Connected World. Our first presentation is Dr. Erin Ryan. He has decided to introduce himself. So, Dr. Ryan, you can take the screen.
All right. Bring up presentation. All right, greetings everybody. And thank you, Alex. Yeah, in terms of a quick intro of myself, after 26 years in the Air Force, mostly doing space stuff, I retired and joined aerospace about 5.5 years ago. And for the first 4 years or so, I was working on space enterprise architecture activities, supporting headquarters aft space. And then about 1.5 years ago, Aerospace stood up its digital engineering integration office, and I moved over to that office and started leading up the development of our digital engineering ecosystem. And then in terms of education, various degrees from various places. So I think with that, it's good to get started. Let me get to the meat of what I want to talk to you guys about today. And there are really 3 sections. And the main one is right there in the middle of the aerospace digital engineering ecosystem. But before that, I want to set the stage a bit in terms of if you're going to deliver, if you're going to achieve and implement a digital engineering ecosystem, it can't be in isolation. So what is that kind of context that it works in? What are those supporting elements that make it more likely that you're going to achieve success? I'm going to talk about that a little bit in the background context. And then we'll dive into the DE ecosystem. What is it? I want to level set everyone on what we mean in terms of the scope and applicability of a digital engineering ecosystem. And then I'll talk a little bit about how we got there, where we're at today in terms of the development of the ecosystem and how we took a misstep at the beginning, and in our opinion, we had to revector and go a different direction that I think has turned out a lot better. So I'll discuss that a little bit and get to some of the details about what we've done in terms of developing a functional architecture for this ecosystem and the beginnings of a physical architecture. And then I'll close things with a discussion of the current status, where we're at right now, and some of the current big challenges that we're facing. All right, background and context. Let me start things off big picture in terms of what our fundamental strategy is. It's really captured in that bang box down at the bottom, and this overall mission statement of what we're trying to achieve with our digital engineering transformation across aerospace is you see these scales that indicate a balance between two key driving factors. And on the left side is our own internal transformation, that focus of making aerospace more competitive, making sure that we're modernizing our capabilities and doing things more effectively and efficiently as part of this transformation. And that would be hard enough, but my job would be so much easier if I only had to focus on the left side of those scales. The reality is we need to also keep in mind the right side and the transformation of our customers. Everyone across government is at some point in their journey of transformation as well, and we want to be able to aid them, to credibly advise them on their journeys and the extent to which I need to develop the ecosystem for aerospace. Well, it's got to be compatible and interoperable across a federation of ecosystem that involves a lot of diverse customers. So that complicates things, of course. And then this shows kind of a roadmap, a cartoon sort of roadmap. This isn't really executable. It doesn't have dates. It has a whole bunch of steps across these swim lanes. I think what I'd call your attention to mostly here is what those swim lanes are, the kind of things that we feel you have to take into account across a digital transformation activity. You've got to nail down the strategy, be committed to doing this, have some sort of governance structure in place that allows you to effectively organize and execute this. You certainly have to think about the resources and how those resources relate back to governance. I mean, the way that you're going to fund this is fundamentally different because it's so cross-cutting. And whether you have to think about indirect costs, you have to think about costs outside of typical program funding channels. It's a big challenge there as well. And then there's the people culture line, which arguably is the most important one on here. I think folks who are immersed in digital transformation probably recognize this is where companies and organizations tend to succeed or fail is right on that line. There's mission needs. There's why you're doing this and demonstrating successes as quickly as possible to the user community. And then that bottom one, ecosystem architecture, where I'm going to focus today, and I'll highlight that. That's the foundation of my mind of a lot of this. So that's to give you some idea of the context. The ecosystem architecture is just one piece of this, and this is what it looks like in a more concrete terms for our governance approach, our lines of effort to do digital transformation. And you see this a lot across the community, that organizations recognize there are a lot of things that have to come together for digital transformation to work. And they typically set up something like lines of effort to get after those. And here's the 5 that we've established. Line of effort 1 is really critical to us. And you don't always see this idea of governance integration across the other lines of effort. Then you see the infrastructure environments where I'm going to focus. There's also the line of effort 3 in terms of authoritative data and models. There's capability development and modernization, and finally workforce education and culture that really gets after that people piece. So as I said, I'm going to focus on line of effort 2 today, and that's really the background in terms of prior to me transitioning into the actual ecosystem discussion. So let's do that. I'll start with, what is a digital engineering ecosystem? Because that's not always commonly understood. So I'll at least describe it and define it in terms of how aerospace views it. And I'm starting with these really big picture, somewhat standardized definitions across from DoD and Space Force sources. You see DAU and the Space Force vision for digital service, how they've described and defined what a digital engineering ecosystem is. And you see a few key themes here across these definitions. One is that an ecosystem is something that is interconnected, it's interoperable across that given organization or enterprise, and it's going to include the infrastructure components, it includes the environments, and even the tools and applications. And in some cases, at least one instance here, it also includes the users as part of that ecosystem. And that's actually the way that aerospace is looking at the users are part of this ecosystem. Fundamentally, an ecosystem it represents that technological foundation to enable digital engineering to work as envisioned and helping users do what they need to do. So kind of applying that to how we've tackled the line of effort 2, the infrastructure environments or the ecosystem part of this, there's the definition again of the scope of line of effort 2, that it's about the development and modernization of not just Aerospace's corporate DE infrastructure, but making sure that that's interoperable with customer ecosystems as well. That goes back to that balance idea I showed at the beginning. A couple key takeaways for us is that the digital engineering ecosystem does form that technological foundation, enables digital engineering across aerospace and linkages to our customers. And really what we're talking about, if you're going to do knowledge management at this scale, it's going to require the adoption of modern infrastructure, environment, and tools. And what that means in practice is adoption of cloud technologies to a significant extent. And clouds provide that ability. The real selling point of the cloud is the ability to access shared pools of configurable hardware and software resources. And those can be rapidly provisioned and provided with minimal overhead to the user. So it's this idea of elasticity or democratization of IT. And that clouds are typically accessed via the internet, but they can be deployed on local networks as on-prem. So when I say cloud solutions for the digital engineering ecosystem that Aerospace is developing, I do mean that full gamut of cloud implementation options from on-prem to various commercial cloud providers, when we intend to have a mix of those as a hybrid architecture solution. Clouds tend to be service oriented. You see these options for compute, store, software development, database, and these are services that clouds provide to users. And as part of figuring out this entire line of effort for a digital entry ecosystem, we have to think about the overall architecture trade space for achieving this. And what does it look like in terms of the multi-cloud ConOps? What does it look like in terms of how we transition from our legacy hardware and all that technical debt to modern capabilities? It's not just a question of one day we can turn on the new capability. We have to think about the transition as well, which is a big challenge. Here's another view of our ecosystem and how we think about it in terms of scope. So on the left, you see this figure that is something we call the cake chart. You can see the layers that comprise the digital engineering ecosystem. And at the bottom, we have this idea of the infrastructure itself, all the foundational IT elements. It's our local networks at various classifications, the storage and compute, virtual machine capability that provides that basic infrastructure. And then above that is this data layer. This is really the heart of the corporate value proposition in terms of supporting rapid capability development and trying to be data centric. And then on top of that is the environment that we set up. This is the mechanism by which humans interact with the layers below that, in particular the data layer, all the application software, all the tools, workflows, and interfaces. And then, like I mentioned a couple of slides back, the people are part of the ecosystem as well, at least in our view. And so those little candles at the top are the peoples that also represent part of the ecosystem, and making sure we account for their experiences and needs within the ecosystem structure. Fundamental to this whole cake chart idea and the idea of how we're going to deploy the ecosystem is something we call E3. This stands for the Enterprise Engineering Ecosystem. And this is what enables users to interact effectively with the ecosystem through catalogs that allow ready access to data, models, tools, software code, or via a service catalog or through customizable workflows. The intent for E3 is to allow users to have a common experience with the actual solution under the hood, transparent to them. They don't know or particularly care where or how those services are provided, whether it's a public or local cloud, or heck, it's a human doing something, for a while until we automate it. But they're getting the service they need. And we make onboarding as painless as possible through this E3 idea of a sort of single pane of glass. So you hear me talk about both the ecosystem and E3 as well in upcoming slides. So let me talk, that's kind of what the ecosystem is to us and the major components. Let me switch gears to what we're doing in terms of our strategy for developing the ecosystem. And here's how we tackled it at first, right at the outset when we stood up our integrated product team and brought in experts to start getting after the architecture. We are a systems engineering company. We have a really strong heritage there. We know how to develop complicated systems, how to tackle that, do the requirements process, and that's essentially the method we used here. We started with a strategy. We developed a few key architecture principles, kind of those non-functional requirements to describe what we want the architecture to do in terms of its survivability, resilience, affordability, interoperability. Those are key drivers to this. And we started thinking about the ConOps that people would use to interact with and do their jobs within this ecosystem. We started developing use cases to capture that and inform requirements. All these things drove aspects of the requirements, that big green box. And we thought, well, that would tell us in traditional top-down system engineering fashion what the functional architecture needs to look like, which could be decomposed into a physical architecture to solve it. And we thought about the needs for a data architecture and what that would look like. This was how we started tackling this for the first few months. But it was slow going, and it didn't really do what we needed it to do in the kind of environment where digital engineering is a very different thing. So that is not where we are today. We ended up going a different direction. And it really was these 4 things I'm showing here which caused us to rethink this and revector. So number 1, speed is paramount to this for all sorts of reasons. We need to make the transition quickly for internal company purposes. It's a smart thing to do from competitive purposes. It's a smart thing to do in terms of not having a long transition period. You want to minimize that period where you're straddling both worlds and you resolve technical debt quickly. So speed is quickly from that perspective, also to help our customers. They're all moving out. We want to get smart on this quickly. Kind of related to that is this idea of culture and confronting those barriers. The longer we take where we're not showing tangible progress and results, and we're moving along that innovation curve and showing more and more people across the company that this is the right way to go, well, the more we're likely to lose momentum here. So kind of 1 and 2 are related. 3 and 4 really drove us to the new approach I'm going to talk about on the next slide. And number 3 is saying, it's asserting that digital engineering isn't just another natural evolution of what's happening in technology, that it's the change from systems engineering to model-based systems engineering. It's much different than that, that this is fundamentally changing how we're doing capability development, how we're performing technical support to the customer. And so the extent that it is a paradigm shift, a complete state change in how we do things, it's not necessarily effective to just look at today's use cases and how we do things today, because it may look very different going forward. So we need to think about that just looking at old use cases and having those informed requirements is not going to be good enough. And then number 4 says, for the most part, the nature of the solution is known. At least if you ascribe to this idea that clouds are a key part of the technology and the kind of services that we need are pretty well established. We know that we need things like compute and storage and software factory and security function. These kinds of things are the basic building blocks for whatever we need to do. So do we really need to spend a year or more doing a requirements analysis to figure out what services need to be provided when we know 80% of the solution out of the gate and we want to go quickly? So this was a really important realization that allowed us to change things up. And the answer is, well, what did we do? Or the question is, what did we do? Well, we pivoted to what I would call a much more agile and incremental approach to the development of the architecture. And so we established these basic principles for the ecosystem versus hard requirements, things you see there like elastic service oriented. And then we attack this more from a middle out perspective instead of just top down. Identify what these services are, figure those out instead of doing a full requirements analysis, and then use those services to provide capabilities to users to help them do their job. And so we satisfy use cases by combining services in a manner that allows them to do their job versus figuring out what that is from a top-down architectural level. And what this has meant for us is a lot of agile principle adoption. Right? We have a lot of engagements going on with users on an ongoing basis, getting that feedback, adjusting it according to that feedback. A lot of reliance on what we call our pilots or minimum viable products to create beachheads and learn as we go. Also, this idea of extensibility. We have a library that we've established that is going to comprise all of these different workflows and what we call service patterns. I'll talk about more in the next few slides that allow folks to actually access what they need more quickly and readily, and then make it sustainable, because what they do ends up building and growing the library for others. And then we're using business case analyses to help us target various transition points and the strategies for adoption as we move out. Okay, so that was all kind of the principles of architecting and our approach. Let's talk a little bit more about where we're at and what this has resulted in. So here you see what we call our level 1 services. We have 9 top level services established as part of our services framework. Things like platform services, data pipeline services, compute, storage, and so on. This is just a quick definition summary of each of these services. What we did for each of these is decompose these into a lower level, which I'm going to show next. But the kind of thing you're seeing here actually should be pretty familiar to anybody who's worked with the commercial cloud providers. Now, you go to AWS, you go to Azure, you see this same kind of breakdown of services. This is a different structure that we're using for our purposes, but the same basic idea. Hey, I want to go get compute functions, or I want to go get infrastructure service. I can subscribe to that through the commercial cloud provider. Well, this is our construct for that. Now, here's an example of decomposition of one of these top level services, in this case, Software Factory, through a couple of levels. So level 1 is the Software Factory. Level 2, we have these functions of plan, develop, build, test, and then release and deliver. And this is actually very closely aligned with the DoD Enterprise DevSecOps, which I think is a good framework for this. Then we decomposed again into this level 3. And for plan, we have configuration management, change management, analysis and design, and so on for each of these level 2 services. There's decomposition shown here. And in this particular case, we stopped. This was what we called an atomic service, because if we did any further decomposition, we weren't really in functional space anymore. We would have to be thinking about the specific solution. So in all cases, we decomposed to a level where we could remain solution agnostic. And in this case, it was 3 levels. In most cases, it was 3 levels, but we did the same thing for all the other services as well. And we did a full decomposition out to these atomic levels of services for each of the 9 top level services. So now we have this entire service framework. I'm going to talk about what that does for our functional architecture. But let me first talk about this in terms of an analogy we like to use to kind of bring this all together, and how this relates to, say, Legos. So if you think of all the individual Lego pieces that you want to bring together to build something, well, these represent our atomic services. These can be mixed and matched into any number of different ways to help satisfy user needs. And maybe we're talking about really discrete sort of services like HPC, high-powered compute capability, or license management, or web hosting. These are really small, discrete things that are atomic services. Well, then there's this other layer. When you start to combine Lego pieces together into frequently used patterns, we call these would be like a module. You have a chunk of frequently used Lego pieces in the same pattern. Well, you just start there instead of the individual Lego pieces. Let's start with that. And those are much more reusable, extensible. We can make those available to users, and we call those service patterns. So, in the real world, we might be talking about all those individual services that are necessary to do extract, transform, load, or containerization. Those types of things might comprise a module. And then in the bigger picture, ultimately, you want to build a project. You want an end-to-end workflow. This is the combination of patterns or individual pieces into something meaningful at the end. So from the user's perspective, they want to go do a requirements management analysis, or a survivability analysis, or develop an ICD, or conduct a technical design review. These are major workflows that represent the same idea as a full-up Lego project. So I'm going to use these terms a little bit in the next couple of slides. And I get to talk about Lego, so that's good. All right, so here's the same diagram or picture of the software factory, and some of these other services are shown off there to the right. What brings value to the user is not the atomic services. It's how you sequence these into a combination that allows them to do their job. And so you can think of this as almost like the capability architecture, a workflow of services that can be combined to do what they want. So, we start out with some sort of workflow management tool within knowledge management, and maybe we establish a security environment, and we go through operations and compute to do certain things, all over to software factory to do certain steps, and back to setting up the virtualization platform, and maybe record this in the data pipeline. There are all these steps that happen as part of a meaningful end-to-end workflow for a user. And so going back to the Lego analogy, the atomic services here, each of these little individual blocks that are highlighted in orange, are the building blocks. They're the Lego pieces that allow you to create a workflow. And then groups of services form reusable service patterns. Maybe every time something like this is done, there are 4 security steps that have to be established to enable the right security environment and set up single sign-on authorization and that sort of thing. Okay, well, let's just abstract that for the user. And then you get groups of service patterns and individual blocks, and now you've got a workflow, and you've got an actual Lego project that's kind of cool. Our idea is that users would leverage existing workflow templates. We start building these up, we put them in libraries. Same with the service patterns, and they pull those in so they're not starting from scratch when they have to build their workflow. We make it as easy as possible for them so that we really have this idea of digital engineering as a service for users. And by growing this over time, we can make this sustainable, because there are so many different workflows possible. But each time we add another workflow to the library as another template for people to use, this becomes more and more deployable, more and more sustainable as we're crowdsourcing all of this together. And fundamentally, we're doing this bottoms up. We're getting the capability out there much quicker than we would if we were to tackle this top down and deploy it all at once. What this means from the perspective of the modeling strategy, something I also wanted to touch on. We're capturing all of these elements I talked about, the atomic services, the individual Lego pieces, the service patterns, and the workflows in a model that we share out to users. So we've got these atomic services, we've got the patterns, we've got the workflows available in the model, and then someone comes along and they want to create a workflow based on this. Well, we also have what we call a stakeholder framework that captures different roles for different users across the company. And the first thing they would be able to do here is filter by their interests. So, whether they're an analyst or they're modeling something, or decision maker, maybe they're a data scientist, whatever role they play, they can first filter based on that and start to get an idea of the workflows that matter to them, search by those, find something that's applicable, and either use it wholesale, it's exactly what they want to do, or more likely they need to tweak it in some way. So they can access those service patterns and workflows through these common libraries, modify it as they need to. Maybe they add a few more atomic services, add a couple other engines to the back of that space shuttle, and now they've got the workflow that they want. If that's good, somebody signs off on that and says, yeah, let's add it to the workflow library, back in it goes for the next generation and subsequent users to access into the workflow library. And so that's the basic idea of what I mean, that this is, it's a self-bootstrapping and sustainable way to keep growing the workflow capabilities across the company. Now, what does this mean in terms of the other aspect of architecture, the solution architecture, the physical components? Let me use an example here of the compute level 1 service, and the decomposition here that we used was platform as a service or infrastructure as a service. And then we broke it down one more level into what you see here in level 3 atomic services. These are still solution agnostic. What does that look like in solution space? Well, this is where E3 comes in. And it provides the actual under the hood solutions for these users who want these capabilities. So if you look at the operating system virtualized advanced compute atomic service there, break that out, and there are different ways that we can provide that. Maybe we'll do it on-prem, or maybe we'll go to one of the commercial cloud providers. And then we break that out. And there are different services that we can either provide on-prem through our infrastructure, or by using services available from the commercial cloud providers. those are allocated down to, these are specific resource solutions that we would provide users. Again, we keep that transparent to them, but this is part of the architecture we need to figure out. And then the con ops for doing that definitely drive solutions. The extent to which we can, we need to be multi-cloud, or we need to keep the mission thread contained in one area will drive how specifically we're providing this solution. And then here's essentially an OV1 type view of what E3 looks like across our vision of this multi-cloud architecture. I mentioned at the outset, there's this balance and this need to support not only the internal transformation of the company, but support our government customers and be interoperable with them and the rest of the community and other contractors, primes and FFRDCs. How are we going to do that? Well, again, if it were just the left side of the balance, we're only focused internally what we needed to do, we might have the luxury of just focusing on one commercial cloud provider and having everything provided by them. That isn't going to work. We need to have at least some presence with all of the different cloud providers, because different customers are going different directions. So we need to be multi-cloud, and we need to be multi-level security within that. And this represents that kind of idea that, kind of in the middle here, you see E3 users who can either access E3 capabilities directly, or more often they're going to go through a digital storefront that makes it easy for them to get the workflows and services that they need. But on the back end here, you see different classification levels, different services being provided at different locations across the country. And then there's a linkage to the commercial cloud, and we'll have an enclave there that we envision will be compatible with different government customer enclaves as well as other contractor enclaves. And again, that's got to be multi-cloud because we're operating all the way up to TSAP to do that. So kind of a cartoon view of what the architecture is beginning to take shape here. I'm going to switch to the last topic here in terms of current status and what challenges that we're seeing right now. So current status, progress to date, we have this functional architecture. I talked about the services framework. First version of that is complete. I'll call it 80% done. We're still tweaking it. We're making adjustments to some of the lower level services, especially. We captured these in a model. I say UML, they're actually mean UAF. Technical leads have been assigned across the board to each of these services to lead up and poncho the maturation of each of these services. And then in terms of what's happening with the solution and the physical layer for achieving the functions, again, that's really the role of E3. And we have connectivity in AWS right now at the IL4 and IL5 levels. We've already exposed to users specific compute and storage services. When they come on board E3, they get these things and can access them pretty easily. We have cybersecurity services already established. We have a software factory service, and that pipeline is established to make the steps for software development as easy as possible and as standardized as possible across the company. We have a catalog stood up where we are capturing all of our data and models. We're still populating this and characterizing the content, but we have the conduit into that so that there's the beginning of a one-stop shop for users to try to get their hands around all of this different content across the company. We have what we call digital sandboxes, which are places where users can begin to learn and practice the various digital engineering capabilities, get experience with tools, and kind of in a safe space, be able to learn how to do digital engineering so that they can become more proficient at it. And then we have customers across the company, operational type customers who are using E3 as well. We're also conducting business case analyses in a few different areas. Our major focus the last several months has been on high-powered compute and how we would provide that capability as part of the new architecture in E3. How much can be done on-prem? How much can be done on the cloud? And what's the right mix? And what are the cost considerations there? These types of business case analyses are just critical to figuring out the transition strategies for adoption and timelines for doing so. And then I mentioned earlier that this idea that we are committed to going quickly to the agile approach. We're using a lot of pilots and MVP approaches. Let me show you kind of an overview of some of the major pilots that have been ongoing the last year or so. So you look at the top there, and you see things start in FY22, and on one side we're really just trying to get our hands around something, just learning, be comfortable breaking things and failing, and demonstrating proof of concept of basic sort of cloud deployment capabilities, and recognizing that all those words on the left are kind of where we started, very stovepipe, legacy development approaches, certainly non-digital engineering, and very product centric. We're trying to move across this continuum to those things on the right, the dream of being truly enterprise and integrating across the enterprise and having those sorts of perspectives, a more DevOps approach, born clouds, so that you're not like migrating things and trying to refactor to get in the cloud. You start there to begin with, and you're able to leverage the benefits of doing so, and being truly data centric versus product centric. That's the idea that these we're trying to get to, and these pilots are trying to push us across that spectrum. So on the left, you see things where we started about 9 months ago of just real low risk kind of stuff. Can we just operate in the cloud? Can we understand the cost for doing so, and some of the basic things of can we just lift and shift content and get it containerized? And we did a few homegrown tools for that. As part of what we called Tranche 1. Then Tranche 2, we increased the applicability and utility of what we were doing, tried to gain confidence in more of the ConOps related to working in the cloud. We had things that were partially containerized, and we got those to AWS, including exposing these to the customer. So now we had an instance where we deployed something to an environment that could be shared beyond our environment. In this case, it was GovCloud, and allowed customers to access that. Right now, we're in Tranche 3, and we have a few efforts going on here, mostly focused on data lineage right now and data-centric approaches, and understanding how to do data tagging across boundaries. And then Tranche 4, sometime soon, hopefully, we'll begin tackling some of the really big challenges related to having hybrid workflows across various cloud platforms and doing multi-level security type ConOps. That's the piloting. In terms of more ongoing work that's happening right now is the services framework. We're maturing that. We'll make sure we aren't missing anything, get past that 80% level. We really want to assign metrics to this and understand the maturity that we're going to characterize for each of these services and how it's developing over time, so that we can actually establish and implement a much more detailed schedule and roadmap for achieving this. We can tell both customers and leadership, hey, this is kind of the timeline you can expect for these things to come. Workflows, we're working with specific users right now to actually begin populating the libraries, getting workflows into the services framework so that we have the beginning of those templates that others can use. What are those key design patterns that can be reused again and again? In terms of E3, working on that digital storefront that you saw in the OV1, that's that front door to accessing these services and workflows, onboarding wizards and things. And also what we're working on here in the near term is getting these services beyond just our unclassified network into at least some of them exposed to the classified level. Like a lot of folks, we're starting out the unclassified. We're not conflating the problem with other challenges. We're working in environment called Anvil to create an instance of E3 in the collateral secret environment to support some customer activities as well. Expanding business case analysis to some other applications. And then data pipeline, I mentioned that Tranche 3 is focused on some of these data-centric issues and data challenges. That is definitely a major focus right now, and it is a nice segue into the challenges, which I'm going to show here on this slide. So the biggest near-term challenges we have, data centricity is a huge beast. Trying to understand the pedigree of data, characterizing that lineage across the life cycle, tagging data appropriately. If you really believe in data centricism and you acknowledge that this is a strategic asset and the tools come and go, this is how you want to have your architecture be structured. But there's a lot of challenges in doing so in terms of figuring out whether that you can actually manage that lineage across data lifecycles. It goes in and out of different tools and is exposed in a number of different places, and trying to figure out what the standards are and imposing them, and what are the governance structures to actually enforce all this. This is a major area of focus for us and definitely a big challenge. Kind of related to this idea of an ASOT, which, generally an ASOT is a very straightforward concept. We all agree that this is the authoritative source of truth for something, but when you start peeling back the layers of what it really means to be an ASOT and how it can vary based on different perspectives of users, it gets a lot more complicated. And so we've started using this term ASOTness to represent to indicate that it isn't really a binary concept that something is an ASOT or it is not an ASOT. It's really more of a spectrum of where it falls on the ASOTness continuum, that there are things that are more ASOT than others. And maybe some things can be certified and they're really good, but everything else, maybe it makes more sense to try to characterize its fitness for purpose for a particular community and allow that community to make their own assessment whether it's the right thing for them. So that's been an interesting discussion point and a major focal area for us, as well as trying to develop a data ConOps which captures all of these elements in a way that is structured and allows us to represent it in the architecture effectively. Another big challenge is multi-cloud ConOps. Like I said earlier, it would be so much nicer if we didn't have to think about multi-cloud, but we do. That's the reality. And so in what way, what clouds are going to provide what workflows and services? How will that range from the on-prem versus commercial clouds? Do we want actually any workflows spanning multiple clouds, and what will that look like? Certainly, what does it look like across security levels and trying to keep things synchronized and conducting configuration management across these different levels? That's a huge challenge that I think everybody's dealing with as well. And then the third item I have listed on here is what I call the digital transformation blueprint. And, it isn't the case that aerospace has the answer for a digital engineering ecosystem by any stretch of the imagination, but I feel like we have the beginning of an answer for that. And to the extent to which we can capture those lessons learned and share those things with others, we'd like to do so. And there isn't going to be a single blueprint for everybody. This is going to have to be tailored, but there probably are heuristics and general strategies for tackling this that we'd like to formally capture and share with the community and ensure that others who are embarking on their journey can do so a little bit more smoothly. And they don't have the re-vectors that we had at the beginning of ours, or at least we minimize this. So in summary, I talked about the importance of understanding the background and the context for a digital engineering ecosystem. This is not something you can effectively achieve in isolation. It has to be done as part of a harmonized strategy with a whole bunch of other initiatives, especially how you're going to govern this. Do you have the right resources? Is the organization committed to this from a strategic perspective? Do you know why you're doing it? And all of that kind of stuff has to be aligned as well. In terms of the actual DE ecosystem and what we're doing, we've established we're going to do this in a services framework approach that's very middle out, more agile, more expandable, more quickly getting capabilities to users sooner, and trying to help with that cultural transformation so that we do maintain momentum. We've established our functional architecture at this point, and we already have a lot of the solution architecture in place, but a lot more to go. I talked about the current status in terms of progress to date and some of the big challenges. And then I just added this little item at the end here about what is next. Again, we don't have the answer, but to the extent that we could work with others across the community who are also on this journey, I would absolutely welcome that. Any opportunities to collaborate with others, share lessons learned, help ensure fundamentally we have interoperability across all of these ecosystems, across the larger space enterprise. The more that we're collaborating now, the more likely I think that we're able to achieve that effective federation. And that concludes my briefing. So I'll come out of slideshow mode here and switch to see if there are any questions.
Hey, Erin, real quick. Thank you for that. We have 15 minutes or so for questions, or maybe 10. One thing, there are a few questions in the chat that you can look through, but I'm also going to unmute allow the attendees to unmute themselves, because I think a few people may have had issues accessing the chat. So you can go ahead and answer the chat questions, and I'll allow people to speak up if they want.
Okay, I'll try to catch up there, and I'll take any audio questions.
Okay. All right, folks, you should be able to unmute yourselves if you have questions. And Erin, I think the first question in the chat is by, let's see here. I think you
from
can
Paul?
see it. Yeah, from Paul.
Yeah, so is the digital ecosystem something the contractor should establish? I think that the only viable way to do this is that everybody's going to develop their own ecosystems, and have some sort of federated approach. So I think every major entity and what those boundaries are is kind of open for discussion, but every major entity should be committed to developing their own digital ecosystem, contractor, government, and so on. Yeah, I'm gonna scroll down. Alex asked the question, no fair, Alex. Is there a public template of atomic services that can be leveraged? We have a definition of atomic services, and we have all of those services captured in a model. But in terms of a template, to me, that really becomes powerful when you start combining groups of atomic level services into something else. A set of a module of kind of things you want to do over and over, or an end-to-end workflow. Does that begin to answer your question?
Yeah, I think so.
Okay.
But he has another question down below.
Okay.
Alex asks again, if you want to read that.
Sure. So the question is, I may have missed this, but how might smaller organizations interact with DEs? I'm thinking from the perspective of resource allocation, how much is necessary? Is there a threshold for who should be trying to implement a DE versus partnering with others to use their DE? That's interesting because that kind of touches on how I answered that first question. I imagine there is, and I don't know what that boundary ought to be. But to the extent that you have control, this kind of goes to the systems of systems thinking in my mind, that there are natural boundaries between systems, which are usually defined in terms of what you have control over in terms of governance, your organization, your budget, what that span of control is kind of determines the size. And if that is really small and you can't meaningfully make these sort of investments, I would think there's probably a size at which it just makes sense to entirely outsource this. Go straight to one of the commercial cloud providers, and they've been doing this for, in the case of AWS, over a decade now. They have this down. Figure that out. I think for some of the big guys, especially on the government side, where they have some very unique requirements, it probably makes more sense to really invest in some sort of intermediate approach for that governance, kind of like what we talk about for E3. That something like that could be much more effective as a single pane of glass, as opposed to wholesale doing it with one of the commercial providers. That's a good question.
And Paul has a follow-up. Are there a set of reference requirements that define the expected ecosystem that can be shared with customers?
Yeah, so the requirements that we have, to the extent that they are requirements, are those ones I talked about that were essentially non-functional, some principles that we want to make sure that we conform to in terms of interoperability and security and affordability and things. The formal requirements aren't there. This isn't requirement driven like we initially thought it would be. Instead, our definition of success is much more along the lines of that incremental agile approach. Are customers getting what they need? Can they do their job better, more effectively? At the outset, can they just do the same job, and maybe it's under the hood and it's happening differently from what they saw, but that quickly allows us to take advantage of some of the digital engineering capabilities. And are they satisfied with that? I think that's my definition of success rather than requirement satisfaction. And can I get a copy of the brief? Absolutely. I don't know what the schedule is for posting it, but I'm sure it's shortly after this, right, Alex?
Yeah, we'll have it up on the website, like Alex Chang said, and there will also be a recording of this. This meeting is being recorded, and so that will be posted on YouTube in a few weeks. It needs to get through security review, but it will be posted in a couple of weeks, and so we'll send out an email when that's available as well. As are all of the previous Systems Engineering Forum events. They are also on our YouTube channel. I guess we still have a few minutes for other questions if anyone wants to come off of mute and ask Erin.
Hi, Erin. Todd Baer from JPL.
Hey, Todd.
More a comment than a question. I just wanted to say, as I have before and what I've seen from the aerospace approach to this, I really appreciate the strategic nature the architecting that you're doing here. I think you really are appreciating and addressing the multifaceted nature of this transformation, and that's often missed in a lot of approaches that I've seen. I know aerospace has a kind of a unique business model, and I think you've also, really well accounted for that uniqueness. We have a little different set of challenges at JPL, but I think it's still very, very valuable to see the architectural strategic thinking. That'll help us, I think, talk to our management in a way that will help. I guess if I had a question, it would be, if you can say, I'd be interested in the rough order of magnitude investment that this has required in the digital ecosystem so far from aerospace.
Oh, that is a good question. I actually don't know if that's something I can say. Why don't Todd, I think I have your email. We've talked a little bit in the past. Maybe it's been a year or so now, but why don't we figure it out via email, especially since we're both essentially FFRDCs. We can probably talk to that in that forum, and let me see what I can release.
That would be great. Yeah, thanks, Erin. I understand.
I mean, I want to. I just probably got to be careful.
No, I get it.
Well, thanks, Todd. Appreciate it. And Manny, good question. How is aggregated ASOT data secured? I talked about some of the challenges with ASOTness. I went down into the rabbit hole of just what it is and how we're defining it and how we're going to make that happen. I didn't even talk about this other aspect to it that you bring up, which is really important too, and that is you want data centralized. You want the most number of people to be able to access this common source as possible, but by virtue of doing so, you are aggregating content. What does that mean in terms of security? That is another challenge I don't have a good answer for. I wish I did, but the more you aggregate, the more these risks grow. And so this is something else that we're having to take into account, but I don't have a solution for you. And if anybody else out there grappling with that has ideas, please reach out to me. This would be an example of where I'd love to collaborate. And then the comment, validation of aggregation is an issue too. Maybe expand on that. I'm not quite tracking what that means to validate the aggregation.
If you want to come off mute and expand, feel free. Otherwise, you can do it in the chat and Erin can address it. Oh, there you go. When you aggregate different ASOTs.
Some thoughts and processing. I'm not quite sure what that means. I'm so sorry. Let me go to the next question. Can you comment on the process to get particular M&S tools get determined to get into the ecosystem? Like, which tools are selected for inclusion in the ecosystem? I think that's your question, Robert. Either if you want to come off mute or say yes, I've got it. I can try to answer that.
Yeah, I apologize. The wording I typed too fast. Yeah, just looking at the overall architecture. Just interested in kind of the methodology and process of for probably more at the use cases of how the tools get determined and how they fit, don't fit, because obviously there's plethora of tools out there. How does that process work? Or maybe that's part of one of the other lines of effort. Maybe you can comment a little bit on that.
No, it's a great question. It always comes down to tools in terms of actually realizing these capabilities. And you'll notice I sidestepped this quite a bit during the discussion. I stayed at that level above in terms of here's what the functional architecture looks like. Here are the services we need to provide. It isn't until you get into that solution layer and specific resources that we do start considering tools. We're trying to be data centric, meaning in a perfect world, we could be tool agnostic. But the reality is we've got to choose a tool at the end of the day. And it turns out that there are relatively limited set of tools that can do, you said there are a lot of tools, and there are, but there are relatively few that can do the kind of things that we really want to do in terms of integrating across data sets and models. And the costs of these tend to be quite a bit more than the previous generation of tools. And so working with the vendors right now, it is kind of part of other LOEs, but it's really a joint effort. Figuring out with these vendors what tools and what deployment modalities, whether they're web enabled, whether they're cloud native, all these things are factors we have to consider in our evaluation for deployment for specific solutions. And then of course there's the backend side. We can't just bring in a whole bunch of new tools and expect users to be comfortable with them. There's training with that. There's friction with getting people up to speed with new capabilities. So the extent to which the tool solutions are part of this is like this whole other endeavor that we are managing as part of the overall digital transformation. But I'm waiting till the next phase of this for the solutioning to really tackle that in earnest.
Great, thank you. That helps.
Okay. Any last questions for me? Okay. Thanks everybody for your time, and thanks to the SEF administrators for doing this. I appreciate it.
All right, thank you, Erin. Alex, I'll pass it back to you.
Oh, so we will take a short break. I know it's not very long, but give yourself a moment to get some coffee or a short snack, or just a little bit of a stretch. We'll be back at 9 a.m. Pacific, which is in about 4 minutes, to talk to OpenMBEE, Connected Engineering Information for a Connected World, presented by Robert Karban and Hetav Patel. So a 4-minute break.
I hijacked the screen meanwhile, if that's okay.
That is fine.
Yes,
you
that's
have
fine.
the screen. We can see it.
Thanks. scary to see yourself on screen.
So we are at 9 a.m. Pacific, and here we have our presentation, JPL's presentation, OpenMBEE Connected Engineering Information for a Connected World, presented by Robert Karban and Hetav Patel. Robert, would you like me to talk to your biography, or would you like to introduce yourself?
No, that's not. Yeah. Let's jump in. I'll mention a few things along the way. It's not so important. So you give me the go, and I go.
Go ahead.
Okay. So before I joined JPL, I worked as a control system engineer for a very large ground-based telescopes in Europe and in Chile. And there's a lot of reviews. And one major difference of how reviews are conducted in the US and in Europe is that in Europe you get 2 weeks, or if you're lucky, 2 weeks before the review, a stack of documents, right, that you have to go through and submit your comments and so on. And I remember one story there. There was a couple of documents, and there's always a lot of technical and engineering data in this model, in this documents, right? So there was a story where there was a number in 2 documents, right, and the context looked similar, the numbers were different, and then people started to argue about what that number is and where it came from, and nobody was able to determine where it came from, or even reproduce it, right? And then went on, and somehow at some point they found out one used the right-handed coordinate system, the other one a left-handed. Classic, right? Well, there's many stories like this. But then in the early 2000s, like 2007, 2008, the model-based system engineering kind of got traction, and I joined the INCOSE initiative for MBSE and was leading one initiative there. And I thought, yes, we'll get rid of all these documents. We'll have only models. So I was giving a lot of talks back then for a few years saying, now we have documents, in the future will be models only. Well, guess what? It was wrong, but like many others. They won't disappear. In particular, in our business, they don't, right? We still have to produce documents, and we have to include a lot of engineering information in those documents still. Right? And often that happens through copy-pasting and other mechanisms, and you have immediately a gap between those documents and the engineering data that you have somewhere else. So 20 years later, time flies, we have taken trying to take a different approach, and this is where OpenMBE came out. It's like we want to connect the information, and we want to update it once, and it should change everywhere else. I might have an engineering model, and the same information is represented consistently across the model and the documentation we have to produce. So let me present that vision that OpenMBE started with and what OpenMBE is today. So in that context, talk about systems engineering, right? And the definition we will use for this presentation is that the system engineers have to guide concurrent collaborative design of complex technical systems. And the major activities is to architecture and design of cyber physical systems, to manage all that complexity, and to provide leadership to the team. And the teams are large. So that's the perseverance team. And they're getting larger and larger, and the systems get more and more complex. And there's more and more hardware, and there's even more software. Why is there so much software nowadays? And that also drives up the complexity. So usually projects start simple, right? You have some engineering models, you have a lot of Excel, typically of documents, PowerPoints, right? And as you go along through the life cycle, the engineers iterate on their models in one way or the other, and enter data into the roll-ups, and add it to a document and get feedback from others, and kind of this network, add it to a spreadsheet, track it over time, send it around, make a change, someone else gets a bunch of other things, right, has to consolidate them. And so it gets complicated rather quickly, in particular with email and Excel. And at some point you're in this mess, right? And there's this little meeple, the guy in the middle that looks at all that and scratches their head, okay? It's becoming overwhelming, right? What do I do with all that? So these are some quotes that we collected. People do a lot of data entry, but they want to do real engineering, right? They don't want to be a janitor of information, but they want to do something else, use their skills. And this kind of maze that you saw before can be kind of reduced to three things, right? Which is the ratio between real engineering versus the overhead. So there's this repetitive data entry, right? There's continuous, you have to enter in one Excel sheet typically, then in another one, and then it has to be consolidated. Then there's this version confusion. Which one is the right version that I have to look for to do my analysis? And the constant search for that information in all those documents and in the models and in the PowerPoint, right? So you spend a lot of time entering data, identifying versions, and searching for the right information. So what the OpenMBEE vision is proposing is to kind of a more structured approach from the mess on the left, right, to get them to a more linked data approach on the right. And you will have still those PowerPoints and the Word documents and Excel sheets, right? They won't go away, and you will have those engineering models, but we want to kind of link them together in a way that that we have that connected data, right? And we update the engineering model, and it kind of flows down through all these other artifacts. And we know which version we're looking at. If we have two documents and there's a number, we want to know where it comes from, who updated it, and what's the source. And this is where we get here. It's kind of this say meme of update once, use everywhere, where we have different models and different documents or artifacts that reference that data coming from those models. And this is somehow where OpenMBEE came out, right? So the OpenMBEE is primarily a community, but it started out with a community which contributes, and JPL is one member. Aerospace is another one, as you might know or not know, and Aerospace has actually become recently a major contributor to OpenMBEE. And people contribute software models, but it's most of all a forum for the people who want to establish a model-based engineering environment and do their digital engineering transformation. So it fits very well with the previous presentation. And there's a number of elements in OpenMBEE. So that's the elements of the software infrastructure. So there's the model management system, which exists, has evolved over the last 6-7 years in different architectural versions and versions within those architectures. But basically, the model management system enables you to kind of collect the relevant information from other repositories. It does not replace anything like other repos, like a requirements repository or some other model repository that you might have. But basically, it builds a graph of those things that you want to cross-reference in your documentation. And we'll see some demos and examples in a bit. The view editor is kind of conceptually the document editor that allows you to author your engineering documents integrating as a linked data element data from engineering models. The model development kits act somehow as a integration element, right? So you have those maybe different clients. For example, the one very popular one is Cameo Systems Modeler. So there's a model development kit that allows you to integrate with MMS. There's a bunch of documentation and training, and lots of presentations. This presentation is actually from our community Google Drive. There is the 30-meter telescope model, which is, as far as I know, well, it's a production model. It's an open source model, which is an executable model, which is built using the OpenMBEE infrastructure. So there are simpler models than that. That's a highly complex model, producing requirement flow down documents, design description documents, interface control documents, based on the OpenMBEE infrastructure, and they're all open source. So that's a good example of a highly complex system that uses that, which is open source and available. And there is something which we call the OpenSE Cookbook, which is a kind of a collection of guidelines and practices around OpenMBEE, how you guide system engineers in the model-based world. So here we see kind of an example of how that could work. You have two roles. Well, you have the model development kits for the engineering model that does do the integration, right? And you have some authoritative source, which is model management system. Again, it does not replace other repositories. It's rather you put everything there that you want to cross-reference in one way or the other, either through a model development kit, through the REST API, whatever. And then you have the document authoring right on the right-hand side. So there is model management system acts as the authoritative source. There's version control. The latest architectural version is fully graph-based. You can put all your ontologies-based data inside and cross-reference it in when you author your documents. So here we see one example. You have two roles. One is a flight system engineer that performs an analysis on the MEL, and the subject matter expert that has to produce a report. And MMS is somehow in the middle, connecting those roles and what they have to do. And hopefully this video works. Let's see. Actually, yes. Okay. So let me pause here for a second. So what you see here is one implementation of View Editor, actually from the so the architectural versions of OpenMBEE infrastructure, they are named after Futurama robots. So this is the Execubot version. And what you see is View Editor, which is the web application to author your engineering documents. And what you see here is like two parts. On the left, you see kind of a containment tree, which are views of the model or of your models, so that everything is based on view and viewpoint paradigm. And on the main pane, you see a table which is generated, but actually references data from your model. And you see around all these little, all the elements, you see some gray wireframes. So every time you see that, you know that is actually not just some text, but it's actually a cross-reference to some data from a system model, for example. In this case, the component, or the owner, or the mass, or the uncertainty. So we can, sorry about that. So we can go in here and we can actually change things, right? And the person who changes it doesn't have to know anything about the model, because that's underneath and transparent. So that person goes in, makes changes to the mass and the component name, for example, saves that. And then there's another person who likes and loves Excel very much and has another view of that same data, right? in the table in Excel. And the data that was changed, you can update in Excel here, right? And you see that the component changes, the mass changes, uncertainty. But not only that, you can go in and add another row, and that will add another component according to the underlying model structure. So that's another commercial tool integration. You commit that, and then you go back to your document view and refresh that, then magically, automatically, the new component will appear, right? So you have this kind of round trip between the person that works on the model engineering side and the person who has to produce a report with MMS as the authoritative source. More recently, we have the OpenMBEE community has been building a view editor where implementation based on Confluence. So what you saw just a minute ago, which is a kind of a custom application, now similar functionality is actually integrated into Confluence, which means that you author engineering documents in the Confluence environment, and the view editor OpenMBEE editions allow you to cross-reference data, right, in a version-controlled, configuration managed way. So let's see a little demo here. So the demo you see here is around requirements. You edit the Confluence page, and you can cross-reference using the hashtag sign requirements by ID, for example, and put them into your Confluence page. We're actively using that for document authoring on the MSR project right now. And you can choose what you want to see, the ID, the text, and so on. Let me fast forward a little bit. So once you save that, okay, let's see. Once you save that page, you can, let's go here. You can actually hover over this cross-reference and see more details about that thing that you referenced. So here's a requirement example, but it could be anything, right? As long as it's as you bring it into the model management system. Right? So cross-referencing is one important thing, and I think that closes this gap that I kind of explained before, right? You don't copy-paste things or manually write it into a document. You cross-reference the actual engineering data, and you know which version it is, and you know where it comes from, right? You have the whole chain of provenance. Another example is like a query-based table. So what you see here is a table which is query-based. You select your requirements by ID, it populates the table, and you know where it comes from when it was inserted. So you have the whole version and CM process there as well. So OpenMBEE infrastructure in the community has grown significantly over the last years. So meanwhile, there's more than 500 members across different industries and other organizations. So users on the NASA side, Mars 2020 and other projects, 30-meter telescope and other organizations. Industry, Boeing has been a big contributor. Standardization bodies like the Object Management Group or INCOSE, but also commercial integrations have become available with the OpenMBEE software infrastructure. So let's look a little bit on the history. So on the JPL side, so one of the first project was Clipper, where the major goal was to reduce the overhead. So were about 100 concurrent users. They produced over 230 documents. But the interesting number here is that there were 445,000 connections between elements. And what does that mean? Usually when you copy paste things and you have all your documents and the data where it comes from, you have all these connections are implicit, right? Because you copy paste them again. But with the view editor and OpenMBEE, they became explicit because they were actually cross-referenced. So the documents were mutually consistent within themselves, but also with the engineering model, right? Because you knew where the source came from. And that is quite an impressive number, because now only we realize how many things, there's probably more implicit ones, right? Because it's usually a process. You start, which we call a model hardening. So you can start with something very informal, right? It doesn't have to cross-reference. It might not even be a model in the beginning, right? You just have your wiki page that you put some text in, but as you go along, you add more and more cross-reference, or you should, and throughout the life cycle, you have more and more formalized your document, right? And you have more explicit connections. There will be always some which are implicit, but we have now the chance to actually have more consistent handling of our documentation and the related model information. For March 2020, the focus was on technical rigor. So there were like 50 users, 90 documents, a couple of 100,000 of connections, and producing documents like reference designator lists, vacuum function lists, and block diagrams, and consistent documentation and engineering documents and models. Skip the quote. Now, the interesting thing about the OMG is the standardization body that produces SysML, for example, is SysML standard and many other standards. Surprisingly, for decades, the OMG people produced all these specifications, which are sometimes several hundred pages, with Visio. So it's not that different than many engineering organizations, right? So they have these specifications for languages are supposed to be unambiguous, but they are produced with someone throws together a Visio diagram and then copy paste it into the specification, right? And that's why people correctly complain that the specifications are sometimes not really great. However, now for SysML v2, and actually for SysML v1, the last version, 1.7, the whole specification was produced for SysML v1, which is like 600 pages or so with the OpenMBEE infrastructure, with an underlying model. There's less connections because it's more model-based, right? So there's much more model behind that. So that's an interesting fact, but there's also less documents. Right? And v2, the request for proposal and the submission, which is like altogether the requirements, the request for proposal and the submission is around 1,000 pages. All that has been also produced with the view editor and OpenMBEE, with a lot of contributors and the number of consumers. So that's kind of the digital transformation of the OMG specification production. So, but the question is, does all that actually scale? That's always the question. And Boeing demonstrated that very well. So for the last, I don't know, 5 years maybe, they started out just using MMS from the GitHub repository, figured it out somehow by themselves because there was not documentation by them, and then became a major contributor. But they scaled that across the whole corporation with 1,000 concurrent users across 50 programs. And similarly, Lockheed Martin at a smaller scale. But Boeing really pushed the envelope of the scalability for the infrastructure. It has been a major contributor all along. So all the previous examples were kind of within an organization. Now Stevens had some collaboration with Naver to see if it actually works also across organizations, right, for model-based acquisition. So they used OpenMBE, and Mark Blackburn, who has been the most prominent representative, and he has a lot of really good presentations on that in great detail, how they used OpenMBE in various contexts for model-based acquisition. And in this little example that you see here is like a model-based sign-offs of documents using View Editor. Right? So that also kind of demonstrates, or they demonstrated that it can work across organizations. So what we have today is this inter-organization environment, right? So update once and see the updates everywhere. Where we want to go is to a inter-organizational concept. We're working currently that with MSR, so there's multiple centers involved, but also ESA in Europe. So we're trying to push that across centers more, and to get to this kind of global engineering ecosystem vision. So in my childhood, I worked at CERN when the first web server actually came online, which was in the early 90s. And I was at JPL when the first OpenMBE server came online. So I hope it will have kind of the same history or future as the web, like the web for engineering. This is kind of the vision of OpenMBE. Here's a quick summary of where we are. It's a community, as I mentioned, right, for open source modeling software and models, open source activities, exchange of ideas. There's a number of organizations that are members and adopters, with more than 500 members meanwhile. We found our home with NumFocus, which is an open source, similar to Apache, open source community. We had in January our 9th in Cozy OpenMBE workshop, and we got just last week, and there will be a ceremony, I think, in the next couple of weeks. We got the award, the Group Achievement Award from the NASA Honor Award. That's kind of very exciting. And we are planning currently for the upcoming Cozy IS, which happens in July, a workshop. So look out for that if you're interested. And thank you very much for your attention. I think Hetav will do a little demo. So we have plenty of time.
Yep.
So Hetav will go and share his screen and show you, and then we can go into questions. Hetav?
Yep, definitely. OpenMBE.org. That allows you to get to our GitHub page, as well as a Slack channel. So we have an open discussion and coordination in Slack that most people can join. And then we also have email lists and Google Drive for people to join as well, coordinating conferences and other talks as well.
Yeah, we have bi-weekly community meetings. So the next on Tuesday, 8 a.m. Pacific. The next one is next week, where we have different presentations from different organizations. So if you're interested, please join.
Yeah. So the demo that Robert earlier gave in the video for Confluence, that is currently going to be the next iteration of OpenMBE products, particularly for MMS and View Editor, having that Confluence integration. Currently, View Editor is a standalone web hosting with the JavaScript backend. MMS is, again, containerized Java application. So that can be deployed via Docker, both View Editor and MMS. The NDK allows for plugin integration with Cameo and other tools, which full information about that is on OpenMBE. the other instance is that if you do need to have air-gapped versions, it is possible. So some of our classified programs have to remove the Docker containerization and have to go to standalone server-based instance. So that is something that can be done. So we do have experience in installing for air-gap systems and in classified spaces as well. So if you have more questions on that, feel free to reach out to me, since I do manage the classified programs at JPL as well. And with that, I think this has been a brief demo. So if anybody have any further questions, please feel free to.
Yeah, I think you can.
Oh, yeah, they're in the chat. Okay.
Yeah, there are a few questions in the chat, and also people feel free to come off mute after he's addressed the chat question. So go for it, Hetav. There are a few in the chat, including some from myself.
Right. So yeah, Alejandro, the first question, we have where it's about to what degree have JPL's concurrent engineering teams integrated digital engineering and OpenMBE concepts? So that is depending on the program. So like some of our classified programs, they're well integrated using OpenMBE and Cameo. Some flight projects are starting to get involved. And then, as Robert mentioned, there are good examples of OpenMBE use cases for current and previous JPL flight projects. The Cameo plugin is readily available. It's on the OpenMBE GitHub page. It's currently the version that's supported is Cameo version 19, SB4, I believe, or SB3. We are upgrading to go to Cameo 2022 later this fiscal year, so we'll be able to announce on the OpenMBE Slack when that occurs. In the spectrum of immediate access to asynchronous work, where do you see the strength of OpenMBE? So as the model grows, seconds might not be as realistic. It might be maybe a minute or less for very large models. So we do have that scaling to deal with. But the strength of OpenMBE is that you definitely get that near real-time update of information. So for our program, a lot of our programs that are not even co-located in the same building, or if they're spread across the world or country or the U.S., you get that near real-time update of information without having sort of that manual copy pasting, as Robert pointed before. So that's a really great strength that's shown its usefulness for projects already. What's my opinion of the sort of information that would suit part of the spectrum better? I'm not sure that. Go ahead.
Yeah, I guess to elaborate, so depending on the kind of information, that kind of information might update less frequently, or some information you want simulation level access where you want it on a millisecond perspective. I guess what kind of information might make sense in different aspects of OpenMBE, or when you're working with OpenMBE, what kind of information have you seen that kind of fits, that you don't need to have that super quick update synchronization? It can have a looser requirement in terms of access.
Yeah, so like the view editor version that exposes the documentation and it provides a real-time update. So you could get a mix of both worlds. So some information gets updated quite regularly and quickly. And so the MMS and view editor and the architecture will be able to handle that. For asynchronous, very sporadic updates, that's also possible, right? So you could have multiple users that are updating at different rates, or you can even have a back-end program that updates the information at a much faster rate, for example. And that's something that can be well coordinated with the OpenMBEE applications. One of the advantages for MMS, though, that we're looking to take advantage of and leverage is not just connecting to just like Cameo specifically, but also integrating with multiple applications, right? So Robert showed an example of connecting with Confluence and connecting with Excel. You could see a platform or a systems engineering environment where you have Cameo, Excel, Confluence, and maybe even a requirements management app, for example, all connected together, and that's all connected with a Python application or another containerized app. So, yeah, go ahead.
I can. So if you check on our YouTube channel, on the OpenMBEE YouTube channel, there are some examples, but the one I want to point out, because they have really done a great job in integration, but also presenting that, is Cetaro Tech, which is a commercial integration. So there's a YouTube video, and they show really very nicely how they kind of close the loop between trading architectures, for satellite architectures, and OpenMBEE and the simulation part, and producing engineering documents. It's really very nicely done. I mean, the whole concept is web service based, right? It's also kind of at JPL, the systems environment where I'm the lead of, is everything is kind of web service based, and we look very much for applications that are API first, right? So the clients are less suitable, so in this I'm the case for the clients, but maybe I can go into that other question from about SysML, UML, right, and other applications. So the limitation of the executable version is that there is some tie to SysML, UML, BPMN, right? Although you can put anything in an MMS, the UI functionality is there is some tie to the meta model of UML. Whereas in the Flexo version, which is where you saw the Confluence implementation on top of that, has broken completely that limitation, right? It's a fully graph-based underlying scalable infrastructure with Sparkle interfaces, REST APIs, whatever have you, and SysML is just one integration point, right, with the SysML v2 API. But both have a REST API, right? And Jupyter has become a primary pillar in our environment, but I think also in the OpenMBEE community. So there have been already with the executable version, so the one we showed, but even more with the Flexo version, with the graph-based version. So everything that can use a REST API can integrate, but it's user-driven. Right? So we have examples where it was with MATLAB and Mathematica integrations. Nobody has stepped up yet for Rhapsody and Papyrus, but we are planning with the contribution, empty contribution, which kind of allows the interchange between Enterprise Architect and Cameo in a common format to integrate that into MMS to have that tool integration. But it's completely open. If someone wants to contribute something, then welcome.
Great. Before we get to the other questions in the chat, is there anyone on the line that wants to unmute themselves and ask questions? I know we're being a little unfair to the voice people, so.
I just had a quick question. Sorry, my mic was up. I just had a follow-up question from the one I posted in the chat, which is just focusing on the arbitrary custom models aspect. Is there support for developing one's own meta model for a specific subject matter and being able to exchange data based on that?
I mean, conceptually, I think, with MMS4, it's probably a little bit more challenging, but with MMS5, I don't see, you can put specify your ontology and use the infrastructure. It's still in development, right? So we have deployed in production, one part of it, but the architecture is much more flexible. And there's information on that architecture on our wiki pages, on the OpenMBEE wiki pages, so you can look there more what is planned and see what the integration points are, like OSLC or SysML-v2 or REST API or whatever have you.
Yeah, the graph-based implementation is a game changer to make it more flexible.
Right, exactly.
Thank you.
The large issue that I've seen is broke. Yeah, I think this is where we're getting to, right? At the moment, I think it's more inter-organizational, and I think the next step is to see how that works, like in the production environment across organizations. So that's something which we still have to figure out, but there are certainly challenges with that.
I have a follow-up.
OpenMBEE is used different in different organizations. So, for example, Boeing has a completely different backend, which is called MarkLogic, right? But the front end is the same. The architecture is flexible enough to allow different deployments, and depending on the use cases or the organizational requirements or needs.
So I have a follow-up to that. On projects that use it, I'm guessing those are more on a voluntary nature as opposed to it being kind of imposed that it needs to be used, or do you find ever that there's kind of any pushback to it? Because I know with anything related to MBSE and DE, there's a lot of cultural changes.
Feeling everything that is not Excel is somehow pushed back.
Yeah.
But there's not really. In very few cases, I see technical limitations. This is all, I think, culturally. It's fascinating to see how many questions are asked about all kinds of things, if it's really the right thing, and does it scale? And not only OpenMBEE, but also like things like Modelica. Is that the right library for us? Does it do all the things we want? And then people leave the meeting and use Excel, right? They don't have any doubts about that. So that I find very fascinating. But this is a cultural thing, right? And I think for the viewer thing, I think for many people, I think it's appealing because it lowers the barrier to access the models and contribute in a way and consume them, that you don't have to know, for example, about SysML at all, right? I think this is kind of a game changer also.
I would add, this is Todd, just, the OpenMBEE, along with the other efforts like OpenCaesar, which you'll hear about later in the summer, and the other a lot of the pilots or, small efforts, they're all voluntary. I guess that's the general answer to the question. We are still looking for projects that are interested in working with us to explore this and become early adopters. So there's no, it'd be nice if there were some top-down forcing function, but we don't have that yet.
For MSR, for the FDID authoring, there has been close collaboration with the line, so that it comes from the project and the line.
Yeah.
This is probably the first time, and that works actually quite well. It's very, and I think the difference is because it has been very user-driven. So there has been put a lot of UX research into, for example, the Confluence integration, what people actually need, right? Not what people come up, what they think we need, what we think they need, right? But actually what they need to do. I think this is a big difference.
And actually, you touched on an important point, Robert. That's worth bringing out. That what we're finding in our matrix organization, which is not every organization these days, but working with our line organization to be the interface to the projects, so that the line provides the people and the expertise and the tooling to the projects, makes it's a more repeatable business model that we're
Right.
fighting. So that's kind of where we're moving to.
Yeah. So there's these kind of three elements, right? There's the user and what they have to do every day, and then there is the business processes that we have to support, and then there is the infrastructure side that has to support both, right? The line processes and the users, they actually can do their work. Like, these are kind of the three elements.
So then, Alex, the last question on the chat that I see. So yeah, the limitations on the base architecture, as Robert mentioned, the MMS4 and earlier, they're tied to a little bit more rigid meta model or architecture. So going into MMS5, a graph-like implementation it seems to be a lot more flexible and allows to the flexibility for users to create meta models for their system engineering use case or system environment use case. So I think when we go towards MMS5, I'm sure we'll have other limitations that we'll find as it gets more mature in production phase. But currently, the flexibility, we're excited for the greater improvement in the architectural flexibility.
Great. Thank you. If there's any last second question on the phone or on the chat, please feel free to hop in. Otherwise, I think we can pass it back to Alex. We can wait a few minutes.
Okay, then I will share the screen for a moment. Okay, go. So again, that was OpenMBEE Connected Engineering Information for a Connected World by Robert Karban and Hetav Patel. Thank you. I just have 2 closing slides, but thank you again to all of our presenters, Erin, Robert, and Hetav, and the event administrators for bringing this all together. Following this event, you can expect 3 things. A PDF version of the presentations will be available for download on our archive site. The recording of this event will be made available on the Aerospace Corporation's YouTube channel within the next few weeks, as well as linked in our archive site. And finally, you should be receiving a feedback survey, just a quick 5-question, 5-minute survey to gather some feedback and more presentation ideas. If you have not done so already, you can join us next month by registering in the SEFaerospace.org for Digital Twins, where we will take a closer look at applications and implementations throughout a lifecycle. And with that, thank you for attending. That concludes today's System Engineering Forum. We wish everyone a wonderful day. Thank you.